Good morning, and welcome to CSIS and to the roundtable with a slightly alarming title, Hurtling Towards a Genomic 9/11. Our time is tight. We need to finish up no later than 10:45. One other housekeeping thing. If you're planning to watch the documentary film, The New Barbarianism, which we put out in September, and we're showing it at 1 p.m. upstairs. Please do get in your seat by 12:55. We're fully booked upstairs. We have to start right on time. I'm J. Stephen Morrison. I'm the Senior Vice President here at CSIS. I direct our global health work. And I'm particularly delighted to be here today with two very dynamic individuals, really no two better experts, to discuss the profound changes and rapid changes underway in the life sciences and what they may imply for misuse of science versus scientific advances for humanity, and what they mean in this instance here today. We're putting a special focus on what they may mean for scientific diplomacy, for U.S. foreign policy and U.S. international security calculations. And that includes a topic we talked about just briefly before starting up here, how we organize ourselves as a government. Hillary Carter, to my right, is Director for Countering Biological Threats at the National Security Council. She's been exceedingly generous to us over the course of the last several months as we've begun preparations for a commission on strengthening America's health security that will be launched in February of this year. We're calling on many of our friends, many of whom are in the audience here today, to help us. I'm undertaking that jointly with my colleague, Rebecca Hersman, from the International Security Program. Welcome, Rebecca. And we're very excited about that. Hillary holds a PhD in cell and developmental biology from Vanderbilt University and has served as a senior advisor in the Office of Cooperative Threat Reduction at the U.S. Department of State. Her work has put her in the thick of the U.S. government interagency process and in extended dialogues with NGOs, international organizations, scientists, our own intelligence community, and many others. David Relman, to my left. Dr. Relman's professor in medicine, microbiology, and immunology at Stanford. He's also the newly appointed co-director of the Biosecurity Initiative at the Freeman Spogli Institute for International Studies at Stanford. Before that, served as co-director for, I believe, 5 years at CSAC, which is a Center for International Security and Cooperation at Stanford, which is a subcomponent of FSI. What's remarkable about this collection of multidisciplinary experts at Stanford is the degree to which over almost a decade now there's been such a heavy focus on looking at the intersection of public health, biosecurity, foreign policy, and bringing in experts from many different faculty into that interaction. Congratulations, David, on the launch of that. It has an explicit goal of advancing the beneficial applications of the life sciences while reducing the risks of misuse by promoting research, education, policy outreach, the very subject that we're trying to address today. Over the past decade and more, he has advised the U.S. government on emerging infectious disease, human microbe interactions, and future biological threats. He's a member of the Cambridge Working Group, which has made arguments dating back a few years now on curtailing the creation of pathogens of potential threat until the benefits and risks were better understood. He has served as a member of the Working Group on Biodefense and the Working Group on Antimicrobial Resistance for the President's Council of Advisors on Science and Technology. He's chaired the National Academy of Medicine's Forum on Microbial Threats for over a decade. And we're just delighted to have you here today from the West Coast, David. Before we begin, I want to thank the team that's putting this all together, Chris Card, Caitlin Johnson, China Holmes, and Brian Mendivas. Thank you so much for all the work you've done. I want to offer a special note of congratulations to Melissa Dalton and her team at the International Security Program for putting together such a stellar set of roundtables and other events today. Hijab Shah has been especially integral and helpful for our plans And on my team, Chris Millard has done a sterling job. Just a few words about our safety precautions. Overall, we're very secure in this building, but as a convener, I have a duty to prepare for an emergency situation. I'll serve as your responsible safety officer at this event. And please follow my instructions should the need arise. It's pretty simple. Our timeline, as I said, is tight. A few quick remarks. The debate we're seeing today as to whether emerging new technologies are dangerous or good, and how do we respond? Do we regulate? Do we heavily control? Do we promote? These debates are hardly new. There's plenty of prior scientific controversies arising over new discoveries and change, oftentimes in periods of turmoil, socially, politically, and otherwise. There are a few common challenges that keep emerging. As David and a colleague, Tom Inglesby, have remarked in their own writings, it's a very difficult field. Imagining, assessing, preparing for biological events may be impossible. In many cases, vulnerability may not be evident until they are tested. A novel pathogen with pandemic potential, a PPP, a quantitative risk for that is oftentimes not possible. And these moments of perceived threat, or moments of heightened perceived threat, they're often coming forward in periods of political, economic, and social upheaval. But I do feel, as reading in for this and as talking to people, I do feel that in this period of the past 5 years, it feels somewhat different than some of these earlier periods. And I hope we'll hear from Hillary and David and other experts in the audience. I mean, in this period of synthetic biology, gene editing, CRISPR, these are new concepts. They're not all that well understood often. The speed and scope of scientific change has been quite remarkable. The profusion and dissemination, the breadth of applications, the ease of access oftentimes. Just with the gene editing, it's much farther and faster than what we had expected. I recall back in early September, Siddhartha Mukherjee, the author of The Gene, and prior to that, the Emperor of All Maladies on cancer. Siddhartha Mukherjee was here in town for the National Book Festival over at the Convention Center, and he gave a talk with a moderator. And I remember him marveling at how, in writing that book, The Gene, he had made what he thought were really bold predictions of things that were going to be seen in X period of time. And by the time the book hit the newsstands, all of those time frames had been shrunk dramatically. And when asked in the discussion around the approach towards applications on human embryos and when were we going to hit that controversy head on, said 3-4 months. And that was in September. And that stuck with me, and as far as what's new and different. We've heard lots of claims of the proliferation of high-risk experiments and the spread of do-it-yourself science. And we're also in an era of elevated skepticism and doubt and mistrust. Public trust and confidence is down. The rise of populism and nationalism have called into question the integrity and value of science. And of course, we have an internet that now has both its dark and its light sides. And we have to ponder that. And we thought until recently that we lived in a period of durable facts and lies, and now we're in a world of fake news and counter-fake news. It's a bit confusing. We've also find ourselves in a very disordered world of multiple open-ended wars, not soon to abate, with ISIS caliphates and cells, a post-9/11 era of counterterrorism, mass migration, fears of migrants in their own intent. And as I said earlier, we're in a period of a new language and new concepts. Synthetic biology, gene editing, gene drives, CRISPR, gain of form. These are things that for the scientists involved are well understood, but I think for many of us, not necessarily well understood. I'm going to skip ahead now. We want to bring our discussion today around questions of regulation and around questions of promotion and advancement. But we want to bring it back also to what these changes imply as a government and as a community of scientists in government, outside of government, interacting. And what does this mean in terms of scientific diplomacy, regulatory harmonization, norms of conduct, standards for sharing and transparency. We want to talk a bit about traditional diplomacy, where these issues are graduating from the technocratic into the political and diplomatic as an element of achieving our means of advancing U.S. national interests, and on how this all ties back to global security interests, readiness, preparedness, protection of the homeland. We're going to do this in a conversational style. We're going to walk through a sequence of just a few basic questions, and then we're going to open it up to you all. And when we get to you all, I just ask that you put a hand up. We'll go around and we'll give you a microphone, and we'll ask you to be very succinct. We'll cluster together 3 or 4 comments before coming back to our experts for their thoughts. So let's begin. Let's begin with the basics. So the first question I'll turn to David to answer, and then to Hillary. For our non-expert audience, and an audience largely focused on global security and foreign policy, David, if you could please begin to explain what are the most compelling changes underway in the life sciences that are stirring these concerns about new unforeseen security threats? And what are the most plausible scenarios for the future where these threats might become more fully manifest? Thank you.
First, let me say it's a pleasure to be here. It's a pleasure to join Steve and Hillary up here. And importantly, I'm looking forward to the conversation that we will have. I know there are a lot of thoughtful people here. As a working scientist, this is a pretty heady and exciting time. It is a time in which we're sort of very much in the midst of an ongoing revolution. The origins of the revolution, this so-called revolution in life sciences, probably began in the middle of the last century. It began slowly, but with some profound new insights and discoveries about DNA and the nature of life. And then it started accelerating much more quickly towards the end of this last century, the late 90s. The first biotech companies arose just in the end of that century. And now we have a full-blown, ongoing revolution. And many have tried to step back and say, well, what is this all about? What's going on? Why? What are the key features? And it's a hard thing to categorize or characterize in that way. But it's partly about capabilities, and it's partly about insight. The capabilities were I think, usefully categorized by a National Academy study. This is now about 10 years ago, which I had the pleasure of serving. And we saw there being 4 categories of new capability that were emerging. The first was the ability to generate new kinds of biological diversity. And this is a lot of technologies, but again, they're all focused around ways of creating new diverse sequences and kinds of function that we don't think ever existed or existed for long in nature. So that's 1. 2, the ability to deliberately design a life form in the laboratory and create one. So for example, almost any virus today can be recreated in the laboratory with the chemical building blocks of its genome and sometimes some accompanying accessory proteins, for example. That's a pretty profound development as well. And it's increasingly a capability that's in the hands of more and more people. So that's number 2. Number 3, the committee said, was the means of understanding complex biological systems, like a cell or an intact organism, in a way that we had really little capability of doing so before, meaning the ability to identify critical pathways and proteins and nodes in the system that could be tweaked or manipulated, ostensibly for good, correct a disease, understand a disease, but possibly for doing harm. And then finally, the fourth were a whole set of technologies around packaging, producing, and delivering biological tools or products, vaccines, for example, or drugs. And these technologies are driven by large economic drivers and interests. So, got these four things going on, and then from them, new insight into how biology works and how biological systems are both dependent on others, but also have critical features that might be, again, the target of a manipulation. So, along with that has come the means of undertaking and executing these capabilities more quickly, more easily, and more cheaply through the packaging of technology in kits, for example, or through the digitalization of biological information, sequence information as code, which can be shared, manipulated, redesigned far more quickly and easily and cheaply. So you've got all these things going on. And to the question, what does this mean about possible future threats? Well, I'd start by saying, remember that these capabilities and insights are immeasurably powerful for the means to do good. But like all good things, there's a flip side. And I think here, to get to your real question, for me, what worries me the most in the near term is many more empowered individuals with many more kinds of motivations, one or small groups of whom might decide to do some relatively simple things like take a known biological threat and tweak it through any of these capabilities I've mentioned to become resistant to our tried and true and heavily invested upon defenses, vaccines, drugs. These are things that we all know how to do pretty easily. And the only question really is why someone hasn't undertaken that kind of deliberate effort to do harm already. We can talk about that. I have some ideas. So I think the bottom line here is, when these capabilities converge upon those that have intent to do harm, the easiest things are to manipulate and tweak the known living things or biological products that we know can cause harm. The future is a much more diverse and complicated set of potential threats. Again, we can talk about if you want to go down those roads.
Thank you. Hillary.
Yeah, sure. Thank you. So first, I want to echo David and say it's such a pleasure to be here. It's a bit humbling to be on the stage with so many experts and familiar faces in the crowd, but it's a pleasure to be here. And thanks to Steve for hosting this important event, especially during the Global Security Forum and getting these issues on the ground. I think the issues that we're discussing today are of critical importance to our national security and of critical importance to our prosperity as a globe. So I won't revisit everything that David said, but I think what you'll find is my comments are very similar to characterizing the problem. I would frame it around three key things. And before I do that, I would say that we've heard experts say that we are on the cusp of a biological revolution. This revolution is going to bring new risks. It's also and new threats, and it's also, of course, going to bring advances. And we're already starting to see the benefits of those. The three ways that we've been thinking about this and have organized the advances is first, that you see the sheer power of biotechnology. We have the unprecedented ability right now to manipulate and modify living organisms. Second, our knowledge of living organisms and of biology is changing and growing exponentially with different tools such as robotics, data analytics, machine learning, and our ability to design and conduct these experiments and the knowledge we glean from them is just increasing. And then third, we're seeing a democratization of biotechnology. Information is widely disseminated, and we've seen that modest investments or modest expenditures can increase significantly the populations who are able to use biotechnologies and perform biological manipulations. In particular, I think the do-it-yourself or DIY community is very robust. It's perhaps as robust as it's ever been. Biological experiments are no longer limited to sophisticated laboratories. Instead, we're seeing people do this in their homes. We're seeing people do this in community laboratories. And biotechnology in general is broadly accessible and no longer confined to these sophisticated research laboratories. And so as a society, I think we're already seeing the advances, the potential for increases in human health and agriculture based on these developments. We've seen that these technologies can revolutionize science, but I think we also must acknowledge, as David said, that there is the potential for unintentional outcomes and also the potential for deliberate misuse. These advances, of course, will help us understand how an organism works and how disease spreads. But on the flip side, that same knowledge can then be used for nefarious purposes. And while misuse perhaps isn't a likely outcome, I do think we should not deny that there is a risk associated there.
Thank you. We're in this period where people are imagining the possibilities and seeing the possibilities, the scenarios as very plausible. But we haven't been hit with a profound and devastating episode. But we've seen around the margins and in various places evidence that has certainly raised the alarm level. And there's been a more active effort at deliberating over what these scenarios might look like. David, could you say a bit more about that? What are the signposts? What's the evidence or data points or episodes that people refer to in trying to think about what the level of risk is? You've been in the leadership side of the scientific community in trying to raise the flag around these issues. How do you go about making your case?
Yeah, it's tough. I think it's telling that there are relatively few scientists out there who will come to meetings like this, or who would even think that they have a place at a meeting like this. It's been relatively difficult, in my experience, to get many of my colleagues engaged in a sustained manner. A number have opinions, but few are willing to think through some really tough problems. And I have thought a lot about why that might be and what we can do to really ground the discussion and make it compelling. Because I don't think we make headway unless we have more meaningful conversations across these disciplinary boundaries than we have had so far. I think, Steve, you're right. Things have advanced significantly over the last 5 or 6 years, and it's probably in part because we've had some serious case examples of advances and discoveries and publications that have made it all very real. Many of my colleagues, I think, hesitate to want to engage on a security problem in the life sciences because, A, they say, there's no real problem here. These things that you imagine might be so harmful, we don't really see happening, or the logistics, the technical features are too daunting. Maybe it's because it's uncomfortable to think about how your work might be misused to cause highly consequential harm to many others. It raises questions about the degree to which we have thought through our accountability to society. It raises questions about what's the nature of our contract with society, we as scientists. So we can go there later. I think the grounding events of the last few years include, as some of you well know, a few papers that came out in 2012. They were published by 2 groups who sought to answer what seemed to be a reasonable question, which is, we've got these bird flu viruses out there in nature, which are circulating like crazy. They're circulating only among birds. These viruses are known to evolve quickly. When they have entered a human by accident in a marketplace in Southeast Asia, the consequence for the human has been terrible. The case fatality rates of these infections in humans by bird flu viruses sometimes is as high as 50 or 60%, 10 times higher than the 1918 flu virus. So the question has been, what will it take, or can these viruses evolve so as to be transmissible now between people and mammals, not just birds? So some of our funding agencies decided this was an important enough question that they would ask scientists to address it head on. And in one case, they actually contracted a group to see if they could take this bird flu virus from nature, highly transmissible among birds, highly fatal in humans, but not transmissible in humans, and deliberately see if they could make it transmissible between mammals in the laboratory, see if it's possible. That was I think, a very humbling, important moment when it was discovered that such an experiment had been contracted and undertaken and then successful, because it raised a number of important questions. To me, it raised the question, are there experiments that we simply shouldn't undertake? Not because the question isn't a great question. It's because maybe there are safer experimental approaches, which I happen to think in this case there were. It raises questions about, well, what if you stumble upon a result that happens to answer a profoundly important question like this, and raises the possibility that someone could now resynthesize a totally new, potentially pandemic virus in the laboratory. What do you do with that information? Is there a way to control information? Raising, again, important questions that you all have grappled with in other areas of science for many years. We in biology have not. So that was a very grounding, important moment. There have been a couple others in the last few years, I think, maybe prompting the motivation for fora like this, conversations like this, but again, the need for much greater engagement by scientists to talk about these kinds of problems. What do we do? What do those no-go experiments look like, if there are such? Do we even agree there are such? That's a big question.
Now, this debate that you've been part of for now over 5 years, really, going back to the H5N1 controversies, it's divided the scientific community in some really significant ways. I mean, you've got the Cambridge Working Group, you've got the Scientists for Science, you've got some pretty significant philosophical and maybe there are political divisions, but they certainly are differences of outlook. There's no clear consensus today, it would seem to me, on these questions that you're putting forward within the scientific community. Is that fair to say?
I think that's fair. I see gradual movement, in part motivated by work of our government and other governments and scientific societies, the national academies here, the European academies, the inter-academy panel. They have all repeatedly raised this particular question. Are there experiments such as this, which ought not to be done? If so, how do we define them? The last administration put forth a policy proposal that said, we will not make new viruses from the influenza virus family that is both highly virulent and highly transmissible, and hence untreatable, essentially, when such a virus did not exist before in nature. Or at least when we decide we think we need to do this, we're going to have a discussion ahead of time and talk about how to. But you're right. There are many of my colleagues who have simply said, anytime you start down a path of thou shalt not, you're now entering a realm of potential danger, of constraint on an inherently and fundamentally important enterprise, the scientific enterprise. Not only the ability to ask questions and address them in a free and open manner, but the means to pursue important questions and define them by the community that seems to know the technical parts the best, and also the means to disseminate the information. This conjures up a lot of concern. And as I say, I think we've made progress, but grounding examples help, and opportunities to sit down and hear from people who know something about the rest of the world and what motivates scientists or non-scientists, and how we might go about looking for strategies to discuss, oversee, monitor, and otherwise govern.
Thank you. Hillary, as both a scientist and an official in the White House trying to think about the future and adjudicate across the different agency interests and the different pulls that come upon you in your office, how do you define what the plausible scenarios are, looking out 3 or 4 years, that you then paint those as possibilities, not certainties, but possibilities growing out of this revolution in biology that we need to prepare ourselves for? And how do you anchor those scenarios in what are a few scattered, fragmented episodes or data points?
So I think, to begin with, I don't know that we will see a signpost of something, any specific signpost that these advances are going to lead to specific outcomes. I think one issue that has led us is looking at horse pox synthesis. So David went through the avian influenza experiments that were done in 2012 and the big splash that those made. I think what we saw recently with investing a relatively small amount of money, with $100,000, a scientist in Canada was able to synthesize horsepox. Why is that significant? Horsepox, right, is it's an animal pathogen. Excuse me. But the reason that's significant is because horsepox serves as a proof of concept for synthesis of smallpox. And smallpox, of course, is an eradicated disease. It is a highly regulated pathogen that only exists in 2 laboratories in the world. So having this indication, which was done by a very well-known orthopox scientist, is significant. And so I think, looking towards the future, Steve, to answer your specific question then, we don't know, and it's very hard to predict what the outcomes will be and where these advances will take us and where we should put policies in place or talk to scientific communities to put guidelines and establish norms and other regulation mechanisms. So I think what that points us to, one place that points us to, is identifying and putting in place response mechanisms. Response mechanisms are critical. We know that if there is some sort of natural outbreak, or an intentional outbreak or an accidental release from a laboratory, the response to that is going to look very similar. And so having those response capabilities, early detection, surveillance, emergency response, emergency operations centers, will all be very critical elements to have, no matter what these technologies bring and where the future goes.
Thank you. There's one tension that runs through all of these discussions, and that's and debate over this phenomenon, this biological revolution, and what it's going to bring forward, and that's the tension over whether this is going to yield major health gains of high benefit to society, side by side with potentially new threats that we really have to grapple with. And that's a difficult challenge to any policymaker to decide, how do you balance those out? You hear this in many different conversations. Better get ready, better be prepared, better think ahead, because otherwise we're going to be caught by surprise at very high risk and very high damage, versus, don't spoil the innovation. Don't dampen and crowd out the scientific gains that could be coming around the corner, which we also cannot see fully. How do you go about striking that balance as a policymaker? And David, I'll get to you in terms of what do you advocate, because you've been in such a strong and deep advisory role on these very same questions. Hillary?
Yeah. So I think you could sum it up in one word, and that is engagement. I think bringing different communities together, whether they're the research communities, the health communities, together with the security communities, is really vital. And I just want to expand upon a few things from the perspective of the seat that I sit in right now. One, I think it is absolutely acknowledged and understood that the benefits to the applications of these technologies are pervasive and they must be preserved. We see biotechnology offering promise in many different areas, as diverse as food security to human health and industrial processing. And so it's essential that whenever you're looking at the security concerns related to these technologies, that you recognize and acknowledge what is at stake if these technologies are constrained in any way, shape, or form. And so the beneficial applications of these technologies must be preserved. I think it's also acknowledged that the risks associated with these technologies are also real, and that there must be steps taken, very carefully thought out, very deliberate steps in conjunction with a wide range of actors that will seek to mitigate and serve to mitigate some of the risks that we see. I think it's also understood that you can't reduce the risk to zero. You're never going to be in an environment where you have zero risk. So you have to understand that as and understand what your risk tolerance could be and what it should be. I think generally speaking, as I mentioned before, there is concern about intentional misuse, but I don't want to undersell the potential for unintentional outcomes. Bioair perhaps poses should be considered a potential threat as well. And because so much is unknown about these technologies and where they will go and how they will go, and the science is so rapidly evolving, it's possible that these unintended outcomes will be the biggest threat that we see. And so because of all of this, the US government spends a lot of time thinking about this, coordinating different policies, and we're continuously evaluating this rapidly evolving landscape to understand how we might better reduce these risks. And in particular, I think we're aware of some of the security questions, and we can get into this maybe later about specific technologies, particularly genome editing and synthesis technologies. Now, scientists will tell you they've been doing genome editing for years and that nothing's new, but I think David outlined some of the changes that we're seeing with some of the new rapidly evolving technologies. And then the last point that I think we consider in this is that there's an acknowledgement that the risks are not confined to the United States. They are, in fact, global. This is a global problem set. Both the benefits that the technologies offer and also the risks are globally available. And these are what we term borderless threats. Any policy that the United States will enact will not reduce the risk more globally. And if clumsily enacted, this could damage U.S. competitiveness, U.S. innovation. I think that is understood. And so, just in general, I think any solution that we identify to this problem will require a global engagement that goes beyond countries and also engages, obviously, private sector, non-governmental stakeholders, academia as well.
Thank you. David, maybe you could comment a bit about your own perspective and that of the practicing scientific community on this balancing act that you face, but also the point that Hillary made about your focus on specific technological changes that require special attention and consideration around that balancing act.
Yeah, this is difficult. There are no easy fixes, obviously. I think we all agree that there are going to be multiple kinds of steps needed, no one of which will suffice alone, and some, in fact, may be quite complementary. So I would start by simply acknowledging that it's been very uncommon for a truly dual-use technology to be addressed in terms of risk and benefit by restricting the use of the technology or by trying to control some critical reagent. This does, of course, work in other kinds of science and technology, sometimes to a limited degree. The nuclear example is probably the best. But in the life sciences, it's hard to identify anything that would be worthy of international control or regulated access. So I think it's less the process and the reagents, and it's more trying to identify what are the intentions that we seek to discourage. What are the kinds of products that we don't wish to produce? And so one example that has been used often is the example of the new potentially pandemic pathogen, the disease-causing organism that is both transmissible, virulent, didn't exist before, and has such properties that would render it difficult to address with our available defenses, biodefenses. I think we don't want to undertake the production of these things without a very specific kind of discussion and a specific set of purposes that we all agree upon are worthy. So that's a kind of product that I think is worth discussing. I think we should also talk about the potential harm that comes from the deliberate but unconstrained manipulation of animal and plant genomes without a similar kind of deliberate conversation ahead of time. And I worry about the technologies that make this more possible, both for good and for harm. So I think there are some examples. And one approach that has worked in some areas of regulation and difficult set of problems is the example of case law, where you, for example, the NIH, through its recombinant DNA guidelines, through the years has established a set of examples of experiments that cross a line that they wish to draw and make clear so that people don't cross without a broader conversation. That's a model that's worked pretty well. Guidelines are, of course, a mechanism that is much more flexible and agile than our regulations. Regulations do serve purposes, of course, and I think we could talk about general purposes that might be useful here, both in sending messages about the kinds of things that we seek to avoid in terms of products and outcomes, but also in helping to set norms as well. But as soon as you get into the business of writing lists of entities that you seek to regulate or ban, in biology, you have a very difficult time because it's very hard to define biological entities in legal terms. We have plenty of examples where that hasn't worked out well. So I think in general, it's a question of thinking about the products and the outcomes and hence the intentions that we seek to avoid or dissuade from being produced, and not going after necessarily the processes, the approaches, or probably in most cases the reagents as well.
It does seem that at a diplomatic level, at a global diplomatic level, there's a new problem set that's in front of us, right? We've got this revolution underway in biology. We've got no clear regulatory framework for much of this. We have a diversity of private sector entities that take many different forms, a diversity of international organizations and governments that are concerned with this. And we've got places that are very disruptive and which may provide havens and the like. And we're at a fairly early moment in the diplomacy around this. There's been some deliberations, there's been some convenings recently of major powers, and others talk about this. But Hillary, tell us a bit about your thinking around what is the diplomacy of the future going to look like for dealing with this particular problem set, which doesn't lend itself to any kind of clear set of steps necessarily. It's not invested necessarily in a single entity. What is, and the goal in terms of what is it you're looking for? Codes of conduct, voluntary forms of normative changes, more strict guidelines by governments. What is your thinking today if the Secretary of State or others come and say, okay, we see this as an emerging issue that has a big diplomatic component to it, but what are we supposed to do?
Yeah. So I go back to what I said in my previous response. I think engagement is critical, and it's clear that governments alone cannot reduce these risks. So these norms or international consortiums cannot be a forum for governments alone. Governments by themselves do not know enough about the state of technology to keep up with the rapidly evolving pace of it, and we don't, of course, control technology to the point of where we are the sole person or sole entity involved. So I think what that leads us to is engagement, and engagement in a way that takes a whole of society approach. One area I think that could use more attention is the development of global norms, a process that most likely must be led by those largely outside of national governments, those such as David, who are at the bench, who are in the field and advancing and pioneering the advances that we're seeing. So I think in certain areas, though, governments do have a role and they do have authority, and they should continue to exert it. One place is, for example, in the select agent regulations, which control access to dangerous pathogens. These will lessen the impact one could say that the select agent regulations will have less of an impact in a future world where you can synthesize different pathogens. But I think what I would say is the select agents also have a criminal aspect to it, where possession outside of the regulations, outside of the appropriate authorizations of select agent material, still would have a component of criminality. And I think there's a strong deterrence factor that could be used there as well. And so while the government has implemented policies to reduce risk by dual-use research and emerging life sciences technologies, there of course are these limits to what governments alone and what government policies can achieve. One potential mechanism, I think, that is in a different sector, but it is a good example, and I know many of you in the room know this example well, is looking at the global health security agenda. So going back to 2013, 2014, there was a lack of international support and international awareness of issues related to global health security. And so a group of countries got together, the US was included in that, and launched what is known as the Global Health Security Agenda. It's a multilateral forum that brings together diverse sectors, as diverse as the biosecurity communities, defense, public health, animal health, environment, brings all of these communities together to think about and generate political support, generate additional funding to strengthen health security to prevent, detect, and respond to infectious diseases. So this has been an overwhelming success, and 2 weeks ago now in Kampala, there was the agreement by 41 countries, non-governmental organizations, the private sector as well, to extend this, what was originally a 5-year initiative, an additional 5 years until 2024. So I think these types of mechanisms are what we can look to when we're thinking about advances in the life sciences. And I think generating the multi-sectoral support for this is difficult. There's certainly a barrier, but I think there are models out there for what we can look to and how to generate leader-level support for these initiatives.
Thanks. David, did you have thoughts on the kind of gaps there may be today in the international domain and how those might best be filled? I mean, Hillary's drawing us back to the Global Health Security Agenda, which has been one very promising initiative that's gone farther than people anticipated, and as you mentioned, was renewed and to a great deal with a great deal of praise, I think, just recently. What's your thoughts on where you sit?
Yeah, I think the Global Health Security Agenda is a great example, and yet I think there's a lot more that can be done at different levels simultaneously. The work of governments, of national governments, is important, and when done in partnerships, I think is even more effective, although nobody would deny the value of leadership roles by some, but in a thoughtful way that doesn't seek to impose, but rather seeks to ask questions. I think there's, for example, a role for the United States in saying, here are some kinds of experiments that we won't do. Now, we may find others in the world who decide that for whatever the reasons, these experiments are not so worrisome, but we find them worrisome, and this is why. And we'd like to talk to the rest of you, the world, about why we feel this way and how we can work through what we think are some potential risks in the life sciences. So I think that's one kind of thing that would be useful. We're going to first need to get enough of us on the same page about that issue, meaning enough of the working scientists of various kinds to agree that there are such experiments or kinds of experiments that we don't think ought to be undertaken. I think there may be roles and uses for law that says, and there probably is law out there in some way, shape, or form that says clear evidence of an intention to do harm with the use of biology is something that we will not tolerate, and there are grave consequences for going down that path. The Biological Weapons Convention was a great thing, but of course, as you all know, it had no enforcement mechanism. There was no inspection regime. It was set aside for various reasons that are understandable, but yet still not worthy of simply accepting as such. So I think we could go further down that road, but again, it's going to require partnerships. There are conversations happening actually today between folks in civil society from this country and folks from the government of India. There are conversations that are ongoing between national academies of the United States and China, et cetera. So those are useful mechanisms. But I then turn and say, at the grassroots level, this cannot be nearly as effective overall as it can be if we don't have the buy-in of a much more global set of scientists, the people who do the work. I think if we could create ways to motivate and inspire scientists to think of themselves as deputies, folks out there on the beat, monitoring and managing the enterprise in a responsible way, we incentivize them by giving them certain responsibilities and empowerment, but we also hold them accountable, because with responsibility has to come accountability, and I'd say that to government as I would to my own colleagues. But we need the world's scientists to both accept that there are some risks, perhaps not on their hallway or in their institute necessarily, but amongst their colleagues writ large, and then to talk about them, say something, and think of what are going to have to be new governance strategies for managing risks of this sort. I don't think there are perfect institutions right now that serve this purpose as is.
Let me ask each of you one quick, big question, but ask for a short answer, and then we're going to open it up for the floor. What do you think, where are the critical gaps in our capacities in our government for dealing with this new world, do you think? What are the areas where we need to be able to have better capacities or new capacities that in order to deal with these realities?
Yeah. So there's a couple things I'd say. I'll simply start for the sake of my own political expediency by saying I think we have done some very good things already. There is more to be done, and in the following sense. I see from the outside our government as fragmented in a way that is counterproductive when addressing what I think should be seen as a unified set of challenges and problems. It's unified across natural, accidental, and deliberate. It should be unified because of its both domestic and international perspective and origin. And it should be unified because it needs to encompass all different sectors of civil society. So it's the academic and commercial and nonprofit and private worlds. It's government in all of its forms. And we're not unified right now. We have too many agencies and departments have their own responsibilities and operate somewhat separately. And when it comes time to a crisis, we haven't planned and anticipated in a general way sufficiently. So I take Hillary's point entirely that the specifics are very hard to anticipate, but the fact that we will have another public health catastrophe or emergency this next year is something that I think we should plan on, and it will have a number of possible flavors, and we should anticipate those now. So coordination, organization, a more consolidated structure, a strategy. We need a national strategy, not just on paper, but one that we're holding someone accountable for executing. We haven't done that. We have a 2004 biofence strategy that has never really been followed up on and pursued as far as our success or not in addressing those stated needs. So organization, strategy, and then the resources, where it's always just in time. Emergency fund needed, never quite provided for ahead of time. And I will say that some of these things were articulated in a letter that was written by PCAST to the president in November 2016. It's available on the web if you want to see some articulation of these needs in a public forum.
Thank you. PCAST is the president's advisory council
for advisors in science and technology.
Thank you. In which that is an excellent report with very concrete ideas. Hillary, you care to say anything about that capacity issue?
Yeah, I'll follow up just quickly because I think David summed it up very, very well. I think what we're missing is a comprehensive approach to look at these threats, whether they're natural, accidental, or deliberate. And I'll take this opportunity to talk about the strategy that the U.S. government is preparing that you may have heard about on biodefense. It's a national biodefense strategy that will be comprehensive in many of the ways that David called out. So by threat, it will look at the naturally occurring, accidental, and deliberate. By target, it will look at threats not just to humans, but to animals, plants, the environment. And by geography, it's not just a domestic strategy. It is a strategy that, again, blurs the line between domestic and international, and so it looks at both. And so it's required the coming together of many of these different stakeholders across the U.S. government, bringing them together to develop this strategy. I think there's been several reports over the past 2 to 4 years. PCAST was mentioned. Another that resonated with many people is the Blue Ribbon Study Panel on Biodefense, and there's been various other non-governmental entities who have called for a strengthened, efficient, coordinated biodefense strategy, and so that's what we're aiming to deliver.
Thank you. Why don't we open the floor, and those who would like to offer quick comments or questions, please just put your hand up. Let's start right here. And we've got a cluster of folks right here. We'll take 3 or 4 at a time. Start over here, and then we'll move over there. Yes, please. Hi. Identify yourself and be very succinct.
Yes, very quick. My name is Rob Levinson. I work for Bloomberg Government. Just last night, I published a piece on the Army giving $500,000 to a small company in Michigan to produce the 3rd generation of transgenic silkworms. They have spider genes in them to produce, spider silk coming out of a silkworm because it's much stronger than steel, pound for pound or whatever. So these are transgenic silkworms. They're out there. They're actually producing in a lab in Michigan, and the Army's just given them $500,000 to create the next generation. I think they're on generation 3. So there's other transgenic organisms out there in industry. Can any of you address what current regulatory framework, if at all, there is on that kind of thing, or what, if there isn't one, what is at all being contemplated? Thanks very much.
Thank you. Right over in this vicinity, there are a couple of other hands up. No? Right there.
Hi, I'm Kevin O'Connell with InQtel. This question is mostly for David, but if you could reflect a little bit on the potential for the synthetic biology toolbox to be a force to shift the advantage to the defense here. How can we leverage it best to counter threats that malefactors might use it to create?
I'm sorry, can you just say that one more time, please?
Sure. How can we best leverage the synthetic biology toolbox to counter threats that malefactors might use that same toolbox to create?
Okay, thank you. Right here?
I wanted to ask you what opportunities and threats do you see coming from the convergence of genomics with artificial intelligence and automation in an increasingly digital space, cyberspace. So they could be opportunities for better deduction of genomic functions on the flight in rapid detection. There could be also more chances for decentralized research and attacks and problems. So how do you see this convergence, helping us or harming us, and how do we rethink the governance tools in the light of that convergence?
Thank you. We have a hand down here. Catherine or Lily?
I got to address this to Hillary. What would be your take on this project, this contest that MIT has been running for a couple of decades now with the amateur synthetic biology community? Because when you're talking about getting a consensus of the scientists, we got a lot of high school students, X, Y, and Z, who knows what. Was that a good idea, or is that a bad idea to be encouraging people who aren't in the, so to speak, the professional ranks to be doing all this stuff?
Thank you. Why don't we pause for a moment and come back, and then we'll do another round. Hillary, you want to start?
Sure, so I'll address that. So you're referring to the iGEM competition that hopefully is well known. It's this competition that engages young scientists, sometimes in high school, typically I believe in universities, on synthetic biology. So I, as a person who used to be at the lab and now as a person who works in government coordinating national security policy, I think it's a fantastic idea. And I think it is a really good example of responsible science. And the reason is they have a fairly robust biosafety and biosecurity component to their work and to this competition. So you see sometimes where the teams are proposing things that have to meet a certain biosafety and biosecurity standard that is bigger than those within their own country, because this is an international competition. So I think in that sense, it is fantastic for demonstrating the power of synthetic biology and what can be done with little resources, but making sure that safety and security perspective is baked into their components is really outstanding.
Did you have any response on the first question around what regulatory framework with respect to Army-funded silkworm case?
I do not have a specific response to that. I'm sorry, I can follow up with you offline. Welcome those in the audience who may know this a bit better than that specific aspect of the regulatory framework better than I, but I do not.
And as for the question around the convergence of genomics and artificial intelligence in cyberspace?
I'll let David respond to that.
All right, David.
Darn.
Over to you, David. And there was one question, Kevin directed a question to you around leveraging synthetic bio against bad actors.
Right. Well, I'd be a little bit insane if I started too far down that path of what are the regulatory features and current landscape around the transgenic silkworm question. But I think, welcome comments, it has a lot to do with what the intended purpose would be. How will it be deployed and for what stated purpose? So for example, if the purpose were to take a transgenic organism or its product and use it for medical purposes, then of course there is a much greater, I think, degree of existing regulation or thinking about how to go about thinking through that problem through the FDA, et cetera. If it were to be released in the environment, then I think it's a very different kind of situation. And there, my own sense, I could be entirely wrong, is that the EPA has relatively little, relative to FDA, little to say about how to govern, regulate that kind of, compound or source. So I think it just depends on the application, is my simplistic answer. On the toolbox, so this is something I think is really exciting because I think what you're really asking about is a toolbox that is immensely broad now and deep. We call it synthetic biology, but I interpret that to really mean any of the tools that allow us to manipulate the material of life, the the genomes and the proteins and so forth. And to me, this is a really exciting area because it really almost is bounded only by one's imagination of what might be tried and what could be possible. So I think there is a great deal of potential. It really depends upon how it gets channeled and by whom. So for example, I like the DARPA Safe Genes program, not to pick on an agency, but there they said, okay, we're worried about a possible misuse scenario or accidental release of engineered host genomes, vectors, insects, et cetera, maybe people. How can we both minimize accidental use of these technologies? How can we enhance our ability to see whether this has happened, detect it, and is it possible to correct it and reverse it? So these were directed questions that helped steer some really great science down paths that both serve an example of what it is that we as society seek to avoid and yet do, and also channel people in useful ways. It's really a question about who tries to promote and incentivize and how the goals are stated. So I think that what you guys do is also equally important because you're inspiring and helping to shape the thinking of a private sector, for example, that could do anything should they choose to do so. And in fact, their investors will reward them in any of a number of possible ways if they can be sold on the idea that what they're doing is both useful and profitable, which this is. So people point to a lot of examples of where the toolbox has been already usefully deployed. And one example is synthetic vaccines, the means of much more rapidly designing and then synthesizing the backbones for vaccines. A derivative technology is the means to create vaccines that are almost produced on the fly for a new emerging problem. And there are some technologies, again, highlighted in the PCAST report that we viewed as very promising that could really change the way in which we think about how to prepare. Because there, it's really a question of putting in place platforms that are agile and quick, that can respond much more quickly to something that was unanticipatable and unanticipated, but allow for a response that could possibly get ahead of the curve of the natural spread of some of these agents. So great question, much more to say. On the convergence problem, I think it's already clear that there's a big business, if you want to put it in that terms, a great financial and economic set of drivers behind the convergence of information technology, informatics tools, and large amounts of data, genomics being one. And you could think of convergences beyond that as well, involving health data, so medical data, environmental data, et cetera. The potential is to generate a whole lot of novel leads about what is critical to an underlying system like people or populations of people. Sorry about that. And then to put in place a bunch of these leads that then can be explored much more deliberately. For governance, though, this is a huge challenge, and I think this is why you raised the question, because what we've done is create what seem to be big black boxes. You pour in a massive amount of data that can never be scrutinized in a sort of deliberate, individualized manner, and then deploy tools that actually are not easy to understand in their root mechanisms of action. And this is where we need to have some serious conversations with, informaticists who can best describe how you choose, modify, design, and then deploy these techniques. Because in some cases, you can get what you ask for. And so we should be thinking about what is it we're asking for and how can we double check on the veracity of what it seems to be saying about a set of data. I've talked to some bioinformatics people at Stanford, and some of them have said, we actually have ways of monitoring or testing for the integrity of a set of data and the validity of an inference from an AI technique. But we haven't been asked, nor are we incentivized to test them in these settings where we're worried about misuse, for example.
We've got time for another round of questions. Down front, we have a couple of hands. Start here. We've got a few minutes left, and then after this round, we're going to come back and ask Hillary and David to offer some closing thoughts. Yes, sir.
Hi, Om Prakash from Northrop Grumman. I'm curious how much about what you've said depends on the U.S. being a world leader in the technology. If the assumption is we're not, would any of the things you've discussed change?
Thank you. Other hands are right here.
Willy Valdivia, Orion Biosciences. I just have a comment in regards to the transgenic organism. Oxitec is a company already releasing transgenic mosquitoes in the United States. The legislation originally was approved by FDA, but now that information is being transferred to EPA, who will be regulating and checking on these, genetically modified mosquitoes. In regards to the forum, I would like to follow up on a comment that you made on the use of information and to what extent, for example, artificial intelligence techniques or computer science techniques can be used to generate diversity that do not exist in nature, but it seeks to deceive and deny the U.S. capability to recognize emerging threats. And, to what extent the intelligence community see this problem as real or close to implementation.
Thank you. Let's take one more back behind here. Right there, that gentleman right there.
Good morning. Ken Kelly, White House Fellow. Let me tie this to the other question here. If you go back to Biological Weapons Convention 1975, U.S. was clearly starting the biotechnology revolution. Asilomar, 77, Roundup scientist-led organization. If you look at the rate of investment of other countries, specifically China, if you look out the next decade, perhaps the U.S. won't be in the lead on these technologies or won't have the power or the moral authority. And so then what happens either from a revision of a new biological weapons convention or from a ground up, citizen scientists getting organized. And a last nuance in this would be there are differences between cultures and morals. For example, the one I would bring up would be manipulating the human germline. And that might vary going forward. So I guess the question for each of you in closing for David and Hillary would be, what would the citizen scientists from the bottoms up do about this, and what would we do from the top down, from the U.S.-led effort before the U.S. loses its lead, if you will, in this area?
Great questions. Great questions. And the first and third obviously sync up closely around U.S. leadership, with more specificity around China from Ted, and the question of the conventions. Over to you, Hillary. You want to lead on that?
Sure. So I'll make 2 points in response to all three of the questions. One, I think there is a significant role for communities to play in a bottom-up way. I think there's been, studies done on this in different sectors outside of biology, looking at what is possible when communities come together and they develop norms, they develop codes of ethics, they develop codes of conduct on how they will conduct themselves and how they will not. So I think there is a very large role for communities and bottom-up approaches and as it applies to this particular issue set. Second, because I know we're short on time, I'll just say that I think there's been a lot of talk and a lot of emphasis on U.S. leadership and what it means, especially in the looking at budgetary implications of some of this stuff. And I've said this before, I'll say it again. And I acknowledge that this is not a position that everybody holds, but I think there's always a role for U.S. leadership in these issues. I think right now the U.S. is particularly well placed to play a leadership role on the convergence of technologies, looking at biotechnologies, looking at bioethics, and there's a role that the U.S. should play here and that we will play moving forward.
Thank you, Dave.
I agree with Hillary on that. I do think that there are approaches that seem to be useful and effective for the U.S. to help motivate and find common ground with countries that might seem to have very different national aspirations. It will never serve the purposes of any nation for an accident or something untoward and harmful to arise from within their borders by their people or by their government. And I think any nation that sits back and thinks about its efforts to move forward really quickly with the potential for an accident or an untoward event that gets linked back to them is going to think long and hard about the importance of trying to minimize that. So I think there is common ground that can be sought and often proves very useful. And never underestimate the ingenuity and creativity of young scientists if they're properly motivated and directed. And they don't see these national boundaries nearly as clearly, as strongly, or as importantly as we sometimes do here.
The question around China prompted one thought, which is, what we've seen in the last year or 2 years around fentanyl and our dialogue with the Chinese. I mean, we've had, I think, 140 new variants of fentanyl introduced in China, and we've been pretty successful at persuading China to cooperate in putting, just in the last year, over 30 on the sanctions list. And that's in a period when we have an emergency on our hands with over 65,000 fatalities this last year from opioid overdoses. And that sudden jump of 20,000 last year was almost entirely fentanyl driven. So there are some important instances at home here that pull back to these same issues. Just to close, we've got about 1 minute, 2 minutes left. I'm going to ask you each, what gives you the most hope here looking ahead in terms of our ability to cope with this new world? Hillary?
Sure. So first, in discussing this talk with one of my colleagues, he suggested that we're all doomed and that the only good news is that something else will kill us first. But with that, I tend to be an optimist, and there's a lot of things that give me hope. One is that scientists of David's caliber is focused on these issues, interested in these issues, started a new initiative they're looking at these issues, so that certainly gives me hope. I think more broadly, there is interest in public-private partnerships. That gives me hope. There's interest there to carry these forward. Initiatives such as iGEM, such as the Emerging Leaders in Biosecurity, those types of things give me hope. We're training a new generation of young scientists to focus on these issues in a way that considers the safety and the security aspects of them. So I think there's a lot to be hopeful for. I don't think, as we've discussed here, there will be a way to predict what is coming in the future and how that will impact the way we live and work. But I have hope that we will work together to find a mutually beneficial solution for all of us.
Thank you. David, you get the last word. What gives you hope?
Well, I'll just say, I'm an unabashed microbiologist. We're living on a microbial planet. This was for 1 billion years a microbial planet exclusively, and it will end up being one at some point. The only question is whether we have some say in the shorter timelines. And I'm also a little bit of an optimist. I'm at a university. Every year there is a new generation or another class of recent high school kids who are immensely talented and inspiring and inspired. And I would say over time, it would seem that they're much more interested, at least in our place, on tackling real world problems, doing something tangible, maybe a little less interest in the theoretical. And this is an opportunity to channel some of that energy. And the other good positive thing I see is some really, really good people in the trenches of all of these sectors, not just the scientist sector, but the security sector. I've done a lot of work as an advisor to the intelligence community. There's some great people who don't get to make the calls on policy necessarily, but they're really doing some good work and trying their best. And if the leaders can't get around to channeling it, in an obvious good way at first, well, then, the forces of suasion and good work may suffice and sway them.
Thank you. Please join me in thanking Hillary and David for a terrific discussion. I do hope you'll enjoy the next round of sessions and hope to see you at the film at 1 p.m.